What up, nerds? I'm Bryson. You can call me Bammed, and this is CTF and Cigars by Bam CTF, where I light up a cigar, I talk about CTFs, hacking, and, other security shit. So, a few weeks ago, I got on here and talked about a recent CTF that we hosted. This was hosted by ConnectWise, mostly put together by the ConnectWise Cyber Research Unit, or the CRU, which is the team I'm the manager of. And let's see, the theme was Let the Nightmare Begin. So the general storyline was we have a bot that the ConnectWise SOC uses called Freddy. Freddy helps triage alerts, and Freddy decided that he's seen the worst of humanity for too long and these humans just have to go. So he set out on a mission to destroy all humanity, managed to build and get hold of a low orbit ion cannon and was going to use it to destroy all humans. So we split this CTF over 5 rounds. Each round had different challenges, different themes, and then there was kind of an underlying challenge that went through the whole thing. There was this bot named Freddy that you had to chat with and get to know and convince him to trust you, and then to finally stop Freddy, you had to actually exploit Freddy, and from there get access to the low orbit ion cannon and send it the self-destruct codes. So a few weeks ago, I went over the crack me's that were spread throughout the CTF. So we had one each round. There were 5 rounds. And this week, I thought I'd go over just the boot to root challenges in the last couple of rounds. So we had some different categories spread throughout. Each round was focused on something different. So like the first round was mainly focused on a PCAP that you had to decode and answer questions about. Excuse me. The second one was mostly OSINT challenges. So there was like a GitHub and a Twitter account that Freddy was using. You had to track down and some other things related to that. The third round was a WordPress site where Freddy was keeping a blog of all of his musings. And then the fourth round was a mail server you had to hack. And then the fifth round was all about hacking Freddy. So what I'm going to go over today, I'm not going to go over everything. We've done the crack me's. There were a bunch of scripting challenges. If you want to see those, you might check out Redhead. Hold on, let me find the redheadsec.tech. So that is Ross. He was one of the guys who helped put this thing on. I just dropped it in the chat if you are in chat. But yeah, redheadsec.tech. Ross did all the scripting challenges, put them together, and he's got walkthroughs on those available on his site, so you might want to go check those out. Coffee. And yeah, today we're gonna go over the boot to root challenges from rounds 4 and 5. So we're gonna just do the end. And to be honest, this is most of the stuff that I actually did. So I did the crack maze, and then I did the round 4 and 5 stuff. And if you were at IT Nation Secure, I know we didn't have a big crowd for that, but because we didn't have a big crowd and those who did participate, we didn't have very many to do the boot to root. We just basically reused the server and added some stuff. So you might have recognized some of those challenges, but oh well. Before I get started, though, I'm gonna light up a cigar. I'm doing something I've smoked before on here. It's one of my favorites, the Oliva Series V Melanio, and this is the Maduro. You can see that. I love the smell of these things. I'm not gonna go into a lot of detail on this one because I've reviewed it on here several times, because I've always got these in my humidor. But yeah, so the Oliva Serie V Melanio Maduro. So this is let's see, it's got an Ecuadorian. No, sorry, that would be the Melanio Natural. So the Maduro, instead of the Ecuadorian Sumatran wrapper, it's using a Mexican San Andres wrapper. The binder and filler are both tobacco from Jalapa, Nicaragua. And oh, just something about the name. It's called the Melanio. Melanio is actually the name of the patriarch of the Oliva family. So the one who started the Oliva family tobacco company. First started growing tobacco in Cuba in 1886. So this has a real earthy, sort of like a hay type smell to it. Yeah, on the cold draw, we're getting a lot of that earthiness. Little musty maybe, and a little bit of nuttiness as well. Light this up, and what we're gonna get is, you know, a bit of cedar. It's the Maduro in particular, you get a lot of sort of chocolate and coffee. Those are some of my favorites to pull out of a cigar. Bit of cocoa powder. A little bit of spicy cedar, and then as you get further into like the second, third, you get a little more peppery to it, and then it gets sort of creamy, and the last about half is pretty creamy. So I'm gonna enjoy this while we look at some hacks today, and I sip on my coffee. This is a cigar that pairs really well with a nice bitter coffee. I like my I like straight black coffee. I like my coffee so black, you have to sign a waiver saying you're not Amish Kapoor or drinking it on behalf of Amish Kapoor. Hope I got the name right. Look it up if you don't get it. Black 2.0. All right. So we're going to hack into a mail server. And the first thing we need to do is find the mail server. So let me see. Am I connected to the VPN? Looks like I am. Let's just do a scan on the VPN and see where our mail server is. Yeah, we'll just do an nmap scan for port 25 real quick. Now, getting into the server actually was pretty easy. You didn't really need to hack your way through. You just need to pay attention to the rest of the CTF. We did this a number of times. A lot of things that you needed for later challenges, you got in earlier challenges. So every time you found something, you needed to keep track of it because it would very likely come in useful later. So to actually get into this, in the first round, in the PCAP, you saw a download from bamctf.com. That's my site. bamctf.com/puppers. And if you downloaded that, you actually got an SSH key. It had a username in it, and of course a flag, but there wasn't really a lot else in that. So let's see, we found our open SMTP port. So this is our mail server, and I've already downloaded this SSH key. Let's see, it should be in my.ssh folder. There it is. All right. So I've got an SSH key and I got an IP address. Let's try logging in. There we go. You can try different usernames, but it ended up just being user, so it shouldn't be too hard to figure that out. I don't think the username was given anywhere that I remember. All right, so we log in, and there we go. Easy. There's your flag. So there's your first flag for this round. All right, now we need to look at doing privilege escalation. Quick thing to check when you're looking for privilege escalation is to look for set UID. So let me start that running. So we've talked about this before on here, but if you're you haven't watched before, if you're not familiar with this, in Linux there are various permissions for your files. You've got and they're all set based on binary, they're bits that are set. So for each set of permissions, there's 3 bits, and then you've got one for user, group, and everyone. So that's the user who owns it, the group who owns it, and then everyone. But there are also some special bits that are set at the beginning. And it's represented in octal. So you just put all those bits together, convert it to octal, and you get this numeric format for how permissions are set. So if a 1 is set in the first bit, that would be 100. So if we're just looking at 3 bits in the permissions, 100 is 4. So a 4, that means that first bit is set, and that's read permissions. 1 in the second bit, that would be 010 or 2. So a 2 would be write permissions, and then a 1 in the third bit is just 001, which is 1. So a permission with the value of just 1 is execute. And then you combine those, so like 101 would be 5, or it would be read and write. And you do that for user, group, and the world. And then of course before that you have the special permissions. And for those you've got set UID, set group ID, and the sticky bit. The set UID and set group ID, the SUID and S group ID basically just is when you execute a file and you've got that bit set, then it'll run the file either as that user or that group. So again, we're talking about 3 bits. The first bit is SUID, so 100, so that's a 4. So I just ran this find command, and we're looking for permissions, and we're looking for them with the 4 in that first bit set. So with this mask, the way it's set up, the zeros it's just ignoring, so it could be anything. It could be read, write, execute for, again, this is user, this is second one's group, and then the third one is everyone. But this first 4 means the set UID bit is set. So we're doing a find on /, which is the entire file system, with the permissions of set UID bit set. And often this is a way you can escalate privileges. You can look for something owned by another user, set UID. That means when that program runs, it's going to run as whoever owns it. So I'll jump to the end here. We're looking for this. This is the thing that we'll find. So this is actually a custom compiled binary. If you're looking through these, there's a site you can use, GTFO bins. And we'll look at that in a little bit when we do another privilege escalation, but it'll go through some common binaries and SUID and how you use that to escalate privileges. But in this case, it's a custom binary, and so we're going to have to figure it out. Now, we could reverse engineer it, figure out how it works, see if there's something we can do with it, but we're just going to start real easy and use strings. Let's pipe this to less, kind of look through the strings and see what it's doing. And there's one thing here, let me find it, that I want to point out. Oh, this is important. It is using set UID, which means we're setting, specifying a specific user ID is running, or at least it's referencing a library that calls that. Here we go. Okay, so, all I already mentioned this is the mail server it's running, and if you do a little bit of research, you'd probably check PS at some point. It's running Exum. So this binary is called checkq exum-bp. If you've ever used exum before, is actually the command line arguments that you use for checking the exum queue. So seeing the current status of the queue. So I want to make a couple assumptions here. I just happen to know they're right because I wrote the binary. But it's calling exum. And notice it's not using the full path. It's just calling the command exum. So it's going to assume that exum is in your path. And since it's using setuid, let's look at this. Look at the permissions here. We can see it's actually owned by root. So this thing is going to run as root, and then it's going to call exum. Now, again, since it's not using the full path, it's just looking for exum in the path. So path, that's capital PATH, is a variable. It's an environmental variable in Linux. That's when you just type in a command, that's where it's going to look for that command. So it's going to look first, and it's going to look in order from left to right, as we see here. So if I just type exum, it's first going to look in user local bin, then if it can't find it there, it'll check user bin, then it checks /bin, then it checks /user local games, and then it checks /user/games. Sometimes if you have multiple versions of some software installed, they might be in different locations. And I've run into some weird issues where things have been like either compiled from source by different people, or maybe they installed something using a package manager and then later compiled it and put it in a different location, where you end up with, just depending where the path is, like the version you think is being called isn't the one that's actually being called. But anyway, the point is that path is a user local or user environmental variable, which means as a user, I can control it. So I've got this program that's going to run as root, and it's going to call exum, but I can actually control what exum it calls, because I can control my path. So I think I did this last night. Yeah, I just made a little shell script called exum that just runs bin sh. I'm using sh because if you actually call bash, it's got some protections built in that kind of can cause some issues with this not working. But sh, you're fine. So that's all this little script is doing. It's just calling bin sh, which is just going to be launch a shell. I'm calling it exum. Now I just need to modify my path. Right now I am in the user's home directory. If you're doing this for CTF, I'd recommend you put it somewhere else, like in a temp directory somewhere, or else, I left this in home. The next user who comes along is going to see it and know how to do this. You don't want to be, giving things away. There was money involved. All right, so let's modify our path. So we'll do export. So it's all caps path, and I'm going to make the first place that it looks is home user, and then I'll just add on the regular path to the end of that, so all my commands still work normally. All right, so now I can call check queue. That's going to run, and all right, well, it didn't make me root, but it made me exum. So probably what the command did, or what that program did, it didn't actually run as root. If you notice, it actually pulled in the library for setuid. That's because, I don't know if I still have the source code for this or not, but essentially it actually set the user ID to the exum user and then called the exum command. So it ran it as exum. So it wasn't as horribly insecure as at first it looked, but I mean, you can still escalate privileges with it and become another user. So it's still not ideal. So that's just a little reminder. If you ever do find yourself in a situation where you need to call another command and you're actually calling it like from a command line, which probably isn't really the best way to do that anyway. But if you ever do, make sure you use the full path. Always use a full path because relative paths can be modified. All right. So for this one, I think there was let's see, there was a flag in var spool. X maybe. Yeah, there it is. So there's our spool flag. Now, one of the reasons I put the flag here is it kind of gives you a hint to where the next the next part of the challenge is. So now that we're XM, we need to figure out a way to become root. Now, if you were paying attention earlier this year, there was I think Qualys released some information. Hold on, I'm looking for it here. Here we go. Qualys blog. There we go. So there were a number of vulnerabilities that were released all at once. In fact, there were 21 vulnerabilities with for XM that Qualys had found, reported on. They all got patched, and they released this document with all the information about them. And they called it 21 nails because there were, 21 serious exploits, several local vulnerabilities and remote. I think there's 11 local and 10 remote, if I remember correctly. But what's important here, if we scroll down here and we look at a summary of what these vulnerabilities are, there's two here that are LPE, or local privilege escalation, from user XM to root. So we are already the user XM and we want to be root. So let's take a look at these and see what they do. Let's just search. There we go. All right. So there's an arbitrary file deletion one. Something about a race condition. Blah, blah, blah. All right. They also mentioned we have not tried to exploit this vulnerability if exploitable, but allow an attacker to obtain the privileges of XM to obtain a full root. Okay. They've got a little bit of information about this one, but reading through the description, it's not. I'm not looking at the right page or right part of the page. Let me find where this is actually being talked about, because I was reading that and I'm like, what is this? This doesn't make sense. This is not the vulnerability I'm looking for. Here it is. Okay, so CVE 2020-28007 was discovered at the end of last year, but it was reported on earlier this year. All right, so you obtain the privileges of the XM user, which we didn't use one of these. We use a different exploit. Then we can use this to become root. There's some information on the code where this is found, or where the vulnerability is found. All right, so this has to do with log files. An attacker with the privileges of the XM user can create a symlink or hard link in a log directory, append arbitrary contents to an arbitrary file. So basically what this is doing is the way XM is accessing log files, the permissions are a bit wonky, and if you have a symlink to another file and you put it in that directory, and for example, the Etsy password, then what you can get full root privileges and like append to that file. So there is a proof of concept here, I believe. Yeah. Wait, I think that's paired with. Hold on, let me make sure I'm using the right vulnerability here. Okay, so there's actually two exploits. This is the one that's more reliable and the one I think I was describing. Okay, so this is create a long named file in the DB subdirectory overflow stack-based buffer. So here's our proof of concept. So we're starting as the exim user. In this case, through a Debian system, it's Debian exim. Go to varspool exim db. Now, again, I was trying to point out that you could do this when I made the challenges. That's why I put the flag in the varspool exim4 directory. So you're mostly there. So they're deleting the last attempt they made. They're going to create a file with a long file name. Calling exim, which will smash the stack and create a symlink. Okay, but here's the actual exploit. All right, let's go back to our VM and see what we got here. All right, so we've already got, someone's already done this. They've created a symlink. Yeah, all right, so we can remove it. But basically, we're doing a symlink from etc password to this retry.password call exim, and then what we're doing is we're appending something. Now after you run the this exim command, it should modify the permissions for etc password. Let me check that. Hold on. Forgot the sh on this doesn't do tab complete. Okay. Yeah, so because someone's already done this on the system, it's already been exploited, and etc password's already owned by exim, by the exim user. But you can achieve the same results. Just copy and paste all these commands here. But yeah, what's happening is because we've made a link between the etc password and the retry.password in this directory, when we call this particular command in exim, because there's a link between the two files, it's actually modifying the permissions on the original file, which is the etc password file. And then we add a user to it, which again I've already done that. Let's look at etc password. There we go. You can see some other people have done the same thing. There's other users here who've done this. And also notice, so if you're looking at etc password, normally the password isn't stored in etc password. It goes in etc shadow, and there's just an X here. But you can put passwords directly in the etc password file. So that's been done here. And again, I've just copy and pasted from the Qualys blogs, reading the same password they were using. But we've also got a user ID and a group ID here, and these are now 0. So user ID 0, group ID 0 is root. If you scroll up to the top of the list here, you can see we only start off with root is user ID 0, and then system users get their numbers until we get to like the actual users, being 1000, which is the admin user on the system, being the first actual user. But anyway, so we've got this user name Francois or underscore Francois. And if we go back to, I'm not switching my screens around. I gotta pay attention to that. Okay, so I looked at etc password. You can see here, it's Francois, user ID, group ID, 00. Okay. Back to Qualys blog, and I swear I'll remember to switch back to the VM this time. most likely. At least 12% chance that I'll remember. Okay, so if we sudo as this user, they've the hash that they're using is radical Edward. So let's copy that command and switch to the VM. Hey, I remembered. We'll paste. All right, password radical Edward. And I'm root. Look at that. That was easy. All right, so there should be a flag in the root directory. Did I miss? Oh, this one it was misspelled. There we go. There's your flag. Okay, so we got to root. A couple of things that were on this. This was a mail server, so we could go reading people's emails. See if I can remember where all those people's emails were. So, all right. Each user has a file called inbox in their directory. If we look at that, we can see emails. All right. I think what we're getting here, I don't think there's any challenges here. It's just a bunch of system stuff. Oh, I should use less. Okay. Okay, now that I can spell. Okay, no, there was one here. I thought this was the user that had it. All right, so there was one email here, and there was a question about, decoding this email. So you may recognize this, you may not. This is a programming language. It's a esoteric language known as Pika-lang, because hold on, let's just grab the top 100 lines. That should be enough. Yeah. So Pika-lang is pretty much identical to brainfuck. So if you watched our Crack Me video I did before, I kind of went over brainfuck a little bit, where you're just it's a complete working programming language, but only has like 8 symbols in it or something like that, where you basically just move your pointer and increment it or decrement it one at a time, and then it's got an option to check to see if something equals 0 and do a loop. But it just uses like greater than and less than sign, semicolon, colon, and square brackets, and that's like the entire programming language. This is the same logic, but instead of using the symbols, it's using various portions of the word Pikachu. So you've got Pikachu, you've got P, you've got PP, you've got Ka, you've got Pika. You can look it up if you want to see how this all works, but there are plenty of resources online where you can go to decode these. So I'm just going to copy all this, and then we're going to switch to a browser and do a bit of Googling. Nope, not Pika-land, Pika-lang. Did not know there was a Pika-land. All right, here we go. Decode.fr. This usually works pretty good. Let's just paste that all in there. Execute. And we've got an email. So this is, let's see. Hey, user. I don't know why you can't pick a cool name like Jason. Anyway, I connected to the LOIC, installed the backdoor. This might come in handy later. Just FYI. Once you align the ground station, well, that sounds like fun. You'll be given a password. Reconnect, use the password to open the back door. Then you can pick a target and destroy as many meat bags as you want. So if you got a chance to chat with Freddie, he liked to call us humans meat bags a lot. And then there's your flag. All right, that's easy enough. Let's see whose other emails we can look at. That's good. All right, so let's just look in the home directory. All right, so we have a few users. I think Monkey was added by somebody in the CTF. Of course, Freddie, I don't know if we have anything in Freddy's or not. Uh-oh. Oh, nope, we got an encrypted message here. It's like something had trouble being sent. Yeah, I don't think there's anything. Oh, somebody was trying to run an exploit. Nothing in Freddy's mailbox, but let's look at Jason. Okay, I just had to reinstall VirtualBox, and I think there's something I need to fix. It's hitting my keys like 5 times. This is annoying. Okay, so Jason has some email. If we take a look at his mailbox, all right, we've got an encrypted message here. It says begin PGP message. PGP, pretty good privacy. You can use the BGP command to decrypt these, assuming you have the private keys. Now, since this is an email to the user Jason, it would make sense for Jason to have the private key stored in his local user's private key share or key store, not share, store. So I had a lot of people kind of get stuck here because they couldn't find the key and import it. But you don't need to import it because you're root. So we can use SU. So SU, normally it converts you to super user, but you can give it the, actually, no, I don't think you need the -u flag. You can just give it a user's name and you can become that user. So Sue Jason, there we go. So now I am Jason. Should be in Jason's home directory. So now I can use gpg-d inbox, and that should decrypt the email in my in Jason's mailbox, assuming that he has the private key stored. And look, he does. All right, so we got an email from didn't decrypt the from, but it's from Freddie. Oh no, here it is. Yeah, good signature. Email from Freddie. Hey guys, I've got a plan. The LOIC is almost ready. It's a low orbit ion cannon. As soon as my bunker is ready, we've got enough bots we can take out humanity, then emerge as the true masters of Earth. Yours truly, Freddie. And there's your flag. The boys are back. Okay, I think that does it for round 4. Round 4 was pretty short compared to some of the earlier rounds. I think, there was a crack me, and I think there was a scripting challenge in there as well. But as far as the stuff on this server, that pretty much does it. So now we can move on to round 5. Now, round 5, this was all about hacking Freddy. So to do that, first you had to get Freddy to trust you. So let's you could chat with Freddie in Slack. Here we go. I was chatting with Freddie this morning. Freddie, say hi to the, let's see what he wants to say. Say hi to the public. He's a little slow sometimes. Destroy all humans. Okay. Yeah, he's got a bit of a one-track mind. So Freddie was a chatbot using Chatterbot, which is a Python library. Excuse me. I trained it on some of the standard training corpus that you can get with Chatterbot, as well as a few lines from Nightmare on Elm Street, if you haven't figured it out. Some of the stuff, Freddy was a little bit based on Freddy Krueger from Nightmare on Elm Street. We changed his name a little bit. It's not spelled the same. We're not exactly that, but since we already had a back bot called Freddy, and it was, Let the Nightmare Begin was our theme because it was Halloween, it just kind of fit. Um, so I trained him on those things, and then he was also just watching the chat and learning from everything anybody said to him. So if you got in the main chat room, you could chat with Freddy. He would respond back. You could also send him a few commands, like he'll tell you jokes or whatever. There are only two hard problems in computer science: cache invalidation, naming things, and off by one errors. Mostly computer science jokes. Um, he did a couple of things. You could check the scoreboard, that sort of thing. But then if the each challenge, or sorry, each round, so again, there were 5 rounds throughout the CTF, there was a trust question. And the idea was you had to convince Freddy to trust you. So you had to get into a private chat with him. He wouldn't discuss it in public. In fact, if you asked him in a public chat room, he'd say, I don't feel comfortable talking about this in public. And the secret was you actually just need to ask him if he trusts you. It was really just looking for there was a regex just looking for the word trust. So anything you said to him, if it had the word trust in it, he would respond with a question. He tells you your current trust level, and then he asks you a question. So I reset him this morning. So right now he doesn't trust me at all. So he says, I don't know you. Current trust level is 0. So we're gonna have to get that up to level 5 before we can exploit Freddy. So he says, who is my father? There were a lot of great answers. I was kind of watching some things people were saying. A lot of people kind of got the Freddy Krueger reference, and so they went back into some Nightmare on Elm Street lore and looking up who the creator of it was, looking up like who Freddy Krueger's father was in the movies, or who his stepfather was, or I don't know. I'm not um, not a horror movie lore fanatic, so I don't remember what the answer to that was. But a lot of different things. People were getting confused, but the answer was actually given to you uh, earlier in that round. So the first thing that you had to do was working with this PCAP, and this was like basically the first question, or there was one just where you had to acknowledge that you read the rules or whatever. But then this was the first challenge. So you downloaded a PCAP, had to answer some questions, and notice it says here that in this PCAP there's a conversation between Bot Father Stu and T-Pop Taylor. So that was your clue. Bot Father Stu. Also, if you go back to, let's see, the homepage, this was brought to you by the ConnectWise CRU. If you scroll down, this is all about our team. And here we go. We've got Stu here. Wouldn't mind a few more bots. There's a couple references there specifically to bots and Stu. So that was your clue, that the answer to Freddy asking, who is my father? It is Stu. There you go. So Freddy wants to make sure you know who he is and you know about him. So that's his first question. You've now raised your trust level from 0 to 1, and you get a flag. Okay, round 2, similar question. Now these were also timed, so you weren't able to ask these before the round started. But it's all over now, so we can just rush through it. All right, so current trust level is 1. What's my favorite movie? Well, you could probably guess. I've already kind of given it away. It's Nightmare on Elm Street. But there was also a challenge in round 2. It's another one of those scripting challenges, or it was a web attack challenge that Ross had put together called Freddy's Fave. And there was a little website where you could pull up different horror, different people from different horror movies, and their look up their favorite movie. And actually, so I mentioned earlier Redhead Sec Tech. So redheadsec.tech. This is Ross's blog. He's actually done a write-up on Freddy's Fave, so you can check that out. He's got a little example here of this is what the site looks like. You pick a character, and it tells you what their favorite movie is. So for Freddy Krueger CRU, because we're the cyber research unit CRU, very funny there, very witty. Yeah, but if you looked it up, it would tell you that Freddy's favorite movie was Nightmare on Elm Street. So Nightmare on Elm Street. Nightmare on Street. And again, all these challenges were using some regex that were pretty permissive. I mean, if you straight up misspelled something, it wouldn't work. But camel case or case didn't matter, and if you had other words in there, it didn't matter as long as the actual answer was in your response. Okay, so that was the second trust question. Let's get to the next one. Now we're at trust level 2. What is my favorite version of them? All right, so round 3 was a WordPress site where Freddy was giving musings about all of his just different things. And in one of them, he wrote a little blog post on how Vim is better than Emacs. So there's a little thing about that. And then if you read through that, there was a question. So Jason had gone on and left a comment and said, what's your favorite version of Vim? And Freddy said the latest version as of today. And then if you checked on the date, it was, I don't remember the date off the top of my head, and I don't have the blog pulled up, but it was like July 14th, 2020 or something like that, or 2019 or whatever it was. You could then go back to the Vim Git repo, go through the history, and we did have a little bit of an issue we hadn't really considered in that we have people from all over the world participating, and the actual update we were looking for was like towards later in the afternoon Central Time, which is where I'm at and what we were basing it on. So for people who were, further east on the other side of the pond of the Atlantic Ocean, it actually would have been past midnight for them, and so it was like the following date. So there's a little bit of confusion, but if you got the date and you tried the different versions around that time frame, then you should eventually come up with 8.1.1364 as the right version. There you go. So now hold on to that. Like I said before, a lot of things we would reuse information from earlier in the CTF for stuff later. If you look up that version, you'll actually find there's a CVE related to this version. So that's important. But let's move on to the next one. This one was pretty easy. Who's my favorite Pokemon? You could, of course, guess. Excuse me. But this was round 4, and we just did the Pikaling challenge. So that was your clue there that his favorite Pokemon was Pikachu. Which, honestly, I think most people, if they guessed, that'd probably be one of their first guesses anyway. So that was a really easy one. All right, then we're getting here to the end. We're now at trust level 4. We got to get to trust level 5. All right, so we've answered all these personal questions about Freddy. Now he's checking to make sure that we're not human. So he's going to give us a math problem. All right, so the prime factors of 13,195 are 5, 7, 13, and 29. So the largest prime factor of 13,195 is 29. So what is the largest prime factor of the number? Best, what do we got? This is let's see, 1,772,683,721. Now I will say this this particular question is a little bit randomized. So there were a few different numbers that he'd pull from to generate this, so not everybody had the same number or the same answer. But there's an easy way to do this. Always going for the easy way. You could, of course, write a script, but you could also just go to Wolfram Alpha. So, what are prime factors of that number? All right, here we go. So there are three distinct prime numbers: 17, 6007, 17,359. Well, 17,359 would be the largest of those. And the question is, what is the largest prime factor? So let's try that. 17,359. All right, now we're at trust level 5. All right, not so mad for a meatbag. I think I can trust you. Read anything interesting lately? So here's a hint. Send Freddy a file to trigger an exploit to move forward. Now, again, you got to pay attention to get the clues that are shared along the way. If you remember all the different questions that Freddy asked, only one of them really had anything related to any kind of exploits. And that was the question about Vim and a particular Vim version. So let's get on the internet. Let's do some research. Let's find the right window. There we go. So Vim earlier than 8.1.1365. Remember, we're looking for 8.1.1364. So, yeah, here is a vulnerability, arbitrary code execution. Well, that sounds like that might be useful. So Vim before this version, vulnerable to arbitrary code execution via mode lines by opening a specially crafted text file. Here's a POC. This one just calls uname when you run this. But what we want to do is actually get a shell on the system that Freddy is reading these files in. So let's go back to our VM here. We'll use netcat. I'll put my IP hasn't changed since I did this. All right, so we're listening for a shell, for a reverse shell. And, oh, actually, hold on. I've already put together a, yeah, here's an exploit of that particular vulnerability that I put together. So what it should do when it exploits it is it's going to connect back to, I believe that's, unless it's changed since I made this, that should be my IP on the VPN, and then port 444, which is what we're connecting to. So let's try sending that file to Freddy and see what happens. Okay, so he says, interesting, I'll give it a read. So what should happen now is Freddy will, okay, my IP's changed. Freddy's going to open this file in Vim. Let me, oh, damn it, I was still connected to the XM server, my bad. Might as well check my IP address while I'm here. Okay, it has changed. Well, let's update the exploit real quick. So my IP should be 172.27.234.81. Okay. So we've got that. Let's start listening again. This time we're on the right host. Oops. And let's send him this new file. So code and it's POC. Here we go. All right, so now he's going to give that file a read. Oh, and look at that. We've got a shell. It worked. So sent the file to Freddie on Slack. He took that file, sent it to a sandboxed, that was supposed to be air quotes, but both my hands are full. A sandbox system. It was basically a Docker image. I think some of this information was given in the challenge as well. But anyway, he opened the sandboxed environment. It was a Docker, and it ran it. Oh, he opened it in Vim because he already told you how much he loves Vim, but it had this particular vulnerability. You exploited it, and it called back to my machine, which was listening. And I'm running as Freddy. I love it when a plan comes together. All right, so we're now a user. Oh, there should be a flag. Bam, there's a flag. Let's become root. So we're gonna do the same thing we did before. Look for set UID. Oh, we're getting a lot of permission tonight. Let's clean that up a bit. Oh crap. Sorry, I shouldn't have Control C. I just disconnected. All right, there we go. We're back. Okay, find perm 4000 and redirect std out to dev null. So again, if you haven't, I don't know how familiar you are with Linux, but there's something in Linux. There's file descriptors, so every file has a number that represents the file in memory. And it's the actual numbers assigned are based on the process. So each process has 3 default file descriptors: stdin, stdout, and stderr. I think 0 is stdin, 1 is stdout, and 3 is stderr. So if something prints out an error, for example, we have all these permission denied errors on the screen that just kind of flood the screen. You can redirect them by 2 greater than, and that will redirect stdout to some location. You can output it to a file, or you can output it, in this case, to dev null. You can do the same thing with std out, which is 1. In fact, the common thing is redirecting std out to, stderr to std out, and then setting them both to a file. That's very common. All right, Toguko, first time watching, can't say today, is it recorded? Yeah, it is recorded. It'll stay on Twitch for a while, but then I put it on my YouTube site. So my YouTube channel is BAMCTF, BAMCTF. You can also go to my website, bamctf.com. That's bamctf.com, and you've got links to my Twitch channel, my Twitter account, and my YouTube there as well. But everything I've done gets saved permanently on YouTube because Twitch only keeps things for like 90 days, I think. Yeah, thanks for watching. Okay, so there we go. We're looking for stuff with the SUID bit set. There's a lot of things here we can look at and do some research on, but this is the one I want to focus on. Python. So we can run Python. It's got the SUID. Let's see what the permissions are on that. It's owned by root, and it has set SUID set. That means if I run something, if I run Python, I can actually get Python to run as root. So we can figure out how to exploit that. A great way to figure that out is GTFO bins. So GTFO bins, just Google it. It's like gtfobins.github.io. You can search for the binary that you're looking for, and this is just different ways you can do privesc or exploit a lot of common binaries. You can search for Python. You can find this. There's some different methods here, but we're looking at SUID. So this is how you can use SUID to Privesk. So there's some different things here. This stuff here actually won't work, but if we get down here, it says that if the binary has the cap set UID capability set, or it's executed by another binary with that set, it can be used as a backdoor. And this basically is what we're looking for. So we're going to run Python, have it execute this command. We'll import OS. Then we're going to use OS to set our user ID to root. So there are, just because it's running as root doesn't mean like if you use os.system, it won't actually run it as root. So we've got to tell OS, the OS library, to use the user ID 0, which is root. And then from there, yeah, just call your shell. So, well, I think I've got this. There we go. I'm gonna copy this, and then switch to the VM. Let's drop that in there. Okay. And I am root. And there's a flag. All right, so now we're root. But if you're going through the challenges, this tells you that you're root on the Docker container. But now we've got to escape the Docker container. There's a number of ways you could possibly set the Docker container, mostly around, I mean, either I guess there might be some vulnerable versions, but a lot of them are around misconfiguration. And one of them is, in some cases, depending on how you're running your Docker image, your container, you may actually be able to access the root file system if you have root on the container, which we do. So let's look at what disks we have. So we've got fdisk-l, and here we go. We can actually see. Normally, we shouldn't be able to see an actual physical disk, and this actually is the name of a physical disk, so we should be able to mount that. The fact that we're seeing it means that we actually would have access to it. Normally, everything in here I think would just show up as like a loopback device. So you can see here like dev loop 8, dev loop 9, dev loop 10. See, I've already mounted this. Yeah, I have. All right, I already mounted this. But let's go to MNT. Just unmount it real quick so we can do it over. Okay. So basically just mount this device to, I mean, you can mount it anywhere. I'm actually just copying somebody else's work. They left this directory here called A. And this is actually the file system of the host, so the Docker host. So essentially, while we can't necessarily interact with processes easily or directly, we do have access to the full file system, and that's all we need to move forward. So the next thing we want to do, we've got to find our flag. This one is in Freddy's home directory, and the challenge was called like LOIC. So you're looking for, how do we access? We're getting to where we're going to actually access the satellite now. So we want to access the low orbit ion cannon. With a bit of sleuthing in Freddy's SSH directory, you can see there is this LOIC key. So you'll want to grab that. But there's still no flag, but if we check in the config directory, so that's where the flag is. And the reason I put it in there is because this is where the other information you need is as well. So there is the IP address for the low orbit ion cannon. It's using this key, and we're using the user Freddy. So that's what we need to know to get into the low orbit ion cannon. All right, let's hack a satellite. All right, so SSH using my key, which I've already downloaded, Freddy at blah, blah, blah. It logs in. All right, so we start getting this information. Last login time, we've got a date, track a sat control system. We've got a latitude, longitude, satellite, Cosmos 2519, start time, 300 observations, 1 per second, waiting for your solution followed by a blank line. Well, what's that all about? Okay, let's talk about this. Oh, all right, let's go back to the CTF site. Here we go. Okay, so here's the challenge that we're looking at. So connect to the LOIC ground station, which is what we've just done. That we've connected to the ground station. And we have to track the satellite. So we've got a ground station with an antenna on it. If it wants to connect to a satellite in space, we've actually got to know where it's at and point the satellite. We've got to track it. So the antenna is controlled by two servos, one for azimuth, the other for elevation. When connected, you'll be presented with some data, asked to compute observations that will be used for tracking. Included is an example file from a previous control pattern. So, okay, so we have an example file to look at that tells us what the data looks like we're looking for. You've got to help line up the antenna, hold on to the flag, you might need it. It might come in handy. Hint, there's an easy solution to this challenge, just takes a little Google foo. So there's actually several ways you could solve this one. One is to figure out how to write a script that does all these things. Takes the longitude and latitude that you've been given, takes the location of the ground satellite, it takes it to the ground station, the actual satellite you're connecting to, the time of day, how many observations you need, all that information, reads that in and calculates your answer. That is the hard way. And if you manage to do that, congratulations, you are awesome. But there's an easy way. Well, there's more than one easy way. There's an easier way and there's like a super easy way. So the easier way is, I mentioned here, takes a little Google foo. I did not create this challenge. I stole it. Yep. So let me find this. First of all, you could find a bunch of write-ups for this. So this is from Hackasat. Okay, let me find the right. I think this. I should have saved the link. Okay, this is Hackasat 2020 challenge. Nope, that's not it. Did I not? Okay, give me a minute. I gotta do some Google foo now. Figure out where this GitHub is at. So yeah, the source code should be available somewhere. Is this it? It was the first link I looked at and thought, no, this isn't it. All right. Okay, so all the source codes. Nope, that's not it. What did I do? Anyway, while I keep Googling. There we go. Okay, so the source code for all the challenges from Hackasat 2020 qualifier is on GitHub. But not only that, so we've got the source code for all challenges and source code for all challenge solutions. So we're looking at the antenna challenge. You've got the source code here. You can see how all that works. But then there's also a solver. So some of the source files it reads in are different, but they were provided in the challenge. So these file that you download. So there's information about satellites in there. They're not exactly the same as the Hackasat 2020 challenge. Slightly different, but you can download this data and use it and use that solver.py. You might have to tweak it a little bit because it was originally designed to like netcat into a Docker image and then execute the code. But instead we're connecting over SSH, so there's some changes there. But you could do that. So you could modify the solver.py, take the information that was provided to you when you logged in, and then copy and paste the output, or actually modify it so it'll SSH in and just do everything for you as well. So that's one way. That would be that was the hard way, which is write your own script. The easier way, which is to use the script that's already on the internet, or you could even follow through some walkthroughs other people have done on that particular challenge from Hackasat 2020. Or the super easy way, because we're connecting over SSH, just you can tell SSH to execute command when it logs in. In this case, we're telling it to use bin sh instead of bin bash as our when we log in, and it just logs you in. So that's the easy way. This actually skips a couple of challenges if we do it this way. And this wasn't originally an intention to work this way. It was a happy accident. Okay, having trouble with my VM doing weird stuff again. Hold on. See if I can type, not have it double type my characters. All right, so challenge.py is the thing. We can, so all the flags just have this nightmare format. So it was nightmare, all caps, inside curly braces was the flag. We can just search for that here and we get, there we go. There's your flag. So that's one way to get that flag. Now, if you did it the other way, so if you either wrote your own script or used the solver.py, when you submitted your answer, it would give you that flag. And then to get to the next step, if you remember the email we read earlier, it said once you line up the ground station, you get a password. Then reconnect, enter that password, and you get to a backdoor. So I don't know how good this is going to work. There's some animation that shows up here, but it's all ASCII animation being replayed over a VM that I'm streaming. I don't know if you can see it or not. But what we've got is here's an ASCII image of a satellite sort of lining up to the Earth. All right, and then we get this little backdoor program here. So we can, acquire a target, enter some coordinates, which those are bad coordinates. So he wants to know, are you a meatbag? Enter some real coordinates. It'll just say, lining it up. Once you've got some coordinates, you can tell it to fire, and then we get an animation of a satellite firing a laser beam to Earth, and there's a big explosion. This was the most fun part of this whole thing for me. Okay, we tell it to self-destruct, so that's our final goal, is self-destruct. But no, you're not authorized. It must be root. Okay, so assuming we didn't do the SSH with the /bin sh-i at the end, and every time we tried to log into the system, this is what we get. So we've got to figure out how to escape this program and get a shell. So one way we can do that there's also this calc program. So you can, enter some math problems here and you get an answer. So 8 plus 10 is 18. If you've been paying attention, everything we've been doing so far is all in Python. So the most likely way we're going to escape this is by injecting something into Python. Now, in this case, this little backdoor thing is just calling eval. Eval, if you just give it any kind of, mathematical problem, it'll just evaluate it and give you the answer. So 100 divided by 5 is 20. But it'll also execute code. So we can inject some code here and use that to get a shell. So easy way to do that. We're going to once again import OS. Then we're going to call, so this is letting us do it all in one command. So it's going to import OS, it's going to call os.system, and then it's going to run bin sh, which just gives us the shell. All right, so there's the different ways that you could get this far, solve this challenge. And there is a flag in Freddy's home directory as well, I believe. Stop double typing, damn. All right, so there's another flag. So once again, we need to privesc. This time it's not a SUID privesc. This one will take a little bit of research. But as you check out the system, you get the current kernel version, this 5.40, blah, blah, blah. Do a bit of research, and you should eventually find that this particular kernel version is vulnerable to this CVE 2021-3493. So this is a Ubuntu overlay FS local privesc. Here's a description. So Ubuntu specific issue in the overlay FS file system in the Linux kernel where it did not properly validate the application of file system capabilities with respect to user's namespace. A local attacker could use this to gain elevated privileges due to a patch carried in Ubuntu to allow unprivileged overlay FS mounts. So there's a source code and there's a POC here. And sorry about my noisy neighbors. And there's a simple way here. It's telling you how to run it. So all you got to do is download this to the system and compile it. I think I already did. Yeah, I already downloaded it. It's exploit.c. Let's call it exploit. Double typing on me again. Damn, stop it. Okay. Gonna compile this exploit. One thing I did notice when some other people were trying this is because it is a file system issue, it has to be run from the file system. So when someone tried to run it from like dev shm, which is actually not part, it's not actually on disk, but it's just in memory. It didn't work. So you got to put it somewhere on the file system. Right now I'm just working out of Freddy's home directory because the CTF's over and it's just me. Normally I wouldn't recommend that. You want to find somewhere private to do this, but here we are. Once you've figured out what the exploit is, you've compiled it. It's super easy if your keyboard works. There you go. You just run it and bam, I'm root. All right, so let's go to root's home directory. This is getting bad. There's a fix for this. I'm gonna have to look this up. I upgraded my MacBook and had to reinstall VirtualBox because of some permission issues, and the fix that I previously applied to this is no longer there, so I'm gonna have to go back and figure out what it was and redo it This double typing thing is super annoying. Okay, so ignore the decrypt.py. I wrote that last night. That's not part of the, well, it's part of our solution, but not part of the challenge. But let's look at this satellite.py. So if you remember when we were looking at our little back door, there was a self-destruct option. And the self-destruct option said you had to be root. So this is the same little back door. So here we go. See, there's our options: acquire, target, fire, self-destruct, calc. We can see the options here. Let's look for self-destruct. All right, so we go to self-destruct. It asks, so instead of telling us we need to be root, this time it asks for authorization code. It gets our password from the input. Then it's running this login and checking to see if login, it's passing our password to it, seeing if it returns a true value. So this login function was here at the top. And this login function is doing something really dumb. We have a encrypted password here. So this is the cryptex. It's looking for a private key. So it's looking in the local directory for a file called loic.pem. By the way, this is not the same private key that we used to SSH in. This is a completely different one. So it's using RSA, loading in this this key, and then it is decrypting the crypttext into this function, or into a variable called decrypted password, and then it's checking to see if the decrypted password is equal to the password that you typed in. Just FYI, this is not how you should ever do a password function. First of all, passwords should not be using synchronous encryption, where you can encrypt and decrypt. Sorry, that's not what synchronous encryption means. You should not be able to decrypt your encrypted password. You should hash it. So hashing is one way. This is asynchronous encryption in that you can encrypt it with a different key than you decrypt it with. You can encrypt with a public key and decrypt with a private key. But the point is, for this to work, we actually need the private key, which we don't have. And if you ever are writing a login function, again, don't use any kind of encryption that can be decrypted. You want to hash it, and then you want to take the input, hash the input, and see if the hashed input matches the saved hashed password. Never save the original password. That's dumb. Don't do it. If you do, your system gets pwned and you deserve it. Okay, so our loic.pem file is missing. Where could it be? It's lost. Well, if you look around a bit, you can find in the lost and found directory, there's all these files. There's a lot of files here. I wonder how many files there are. Let's count them. 892 files. Okay, so we've got a lot of files in here. Let's see how many of them are keys. Run the file command on lost and found star, and basically what we have, each of these are key pairs. So we have a private key. So here's the private key, and then this ASCII text, if we look at that. Oh, yeah. I swear I know how to type. Here we go. That's the public key. So each of these are a private key and a public key. So we could assume one of these are probably the keys we need, but which one? So this is where we're going to have to figure it out. We could do a simple script that just goes through each one and tries it until something works. And I've already done that. So all I did here is I copied the login function. Instead of accepting this is just a Python script. All we need is the RSA library and the sys library. Actually, do we need sys? Oh, we do, because we're getting arguments. Yeah. I copied the login function, and if you remember the login function, it's had the saved or the encrypted password. Then it loads the private key. So this time what we're doing is I'm just going to run this. I'm going to pass it a file name. It's going to then read that file, and then it will use that file to try to decrypt the password. And if it decrypts it, it will print it. So there's that function, and then all it does when you run it, it's just going to do login and sys.argv1, which is going to be the first argument after the command name. So okay, hold on. If we look at, I'm going to make this run a little bit quicker. So if we look at the lost and found, notice the private key is larger than the public key. So this is about, a little over 3K, and this is like 700 bytes. So let's see. Yeah, I did this before. Here's the easy way. We're going to do a find on lost and found dash type F. So we're only going to look for files. And then we're doing a size of greater than 3K. So that way it's only going to return, it's just basically going to list all of the private key files in this directory. Assuming there aren't any other files in here, I'll tell you that right now there aren't. But then it's going to go through each file. It's going to print out the name of the file, and then it's going to run the Python, the decrypt.py that we just looked at, and pass the file name. I just want that so I know which file it is, because I want to show you what happens when you get the password. And then, again, we're going to ignore any errors. All right, so we'll let that run, and we already got the Okay, stop. Anyway, there we go. It didn't take us very long. We found it. There is there's the key, and this is the file. So let's see what happens when this works. Stop. What are you doing? So okay, I'm definitely fixing this as soon as I'm done, because this is driving me insane. I actually just installed VirtualBox last night, which is why I haven't noticed this double typing thing before now, because I just did this. Okay, so let's copy that to what was it? LOIC dot. That's a lot of C's. .pem. I'm in the right directory, right? Let's just assume that okay. Let's copy this password. Wow. It is getting worse. Let's run the satellite script. Okay, so again, this is the same thing as before. You can acquire target, fire. But this time when you run self-destruct, it wants authorization code. Well, that's going to be our final flag. And success. And we get another little animation. Again, I don't know how it shows up on the stream, but this was a satellite falling into orbit and burning up in orbit, or burning up in the atmosphere. So it's falling out of orbit, burning up in the atmosphere. And ta-da! We destroyed Freddy's low orbit ion cannon. We've saved the world. Humanity is safe once again. And that's it. That's the final challenge. So, for those of you who participated, I hope you enjoyed those last couple rounds. I noticed not a lot of people actually were able to finish all of the final round. Getting that Vim exploit to work was challenging for a lot of people, because you were completely blind. we gave out a lot of clues, try to point people in the right way. We kind of told them, I think a couple times, if you're paying attention in chat, that Freddy was using BEM, and then it was kind of up to you to remember and pay attention to the fact that Freddy told you he's using an older version of VIM with a vulnerability, so that when you sent the file, he opened it. Some people had trouble getting the exploit to work even after they found it, and if you had trouble, what I recommend is actually finding that vulnerable version of it, download it, compile it, and then working locally. Because again, Freddy didn't give you any output. It worked or it didn't work, and you just had to keep trying. So a good way to test these things is to try to duplicate them on a local system, and so you can actually see the output and figure out what went wrong. I know one problem some people had is if you didn't include a new line at the end of the line, it would open Vim and it would open up the command that you needed to enter to exploit it, but it wouldn't actually execute it. It was waiting for somebody to hit enter, essentially. So you had to have a new line at the end that would actually execute the vulnerability. So yeah, that's the end of the Nightmare CTF, or let the nightmare begin. Again, I hope everybody who participated had fun. We'll be doing another CTF sometime next year. Well, I'm sure we'll be doing more than one. Stay tuned, and I'll let you know when that's coming up. Try Hack Me is doing their annual Christmas thing. That's coming up here in December. So, go to tryhackme.com. I'm not affiliated with them or anything, but it's always a fun challenge. And I'll probably, I did this last year, so I'll probably do it again this year. Kind of go through each of the challenges and I won't be doing it every day, but maybe like every weekend, going through the challenges from the previous week. It's a lot of fun to do, so I recommend you check that out. And I already mentioned this, but yeah, if you want to see other content I've done, bamctf.com, bamctf.com. It's got links to all the things. If you watch the crack me's that I did a few weeks ago, I've actually got those crack me's up on my GitHub. Again, the link is on my site. You can also follow me on Twitter at BAMCTF for any updates on new content that I'm going to be putting out. And yeah, that's it. I'm tired. That's good enough for today. So thanks for watching. I hope this was instructive and helpful. If you have any suggestions, if there's any content that you're wanting to see, let me know. Just again, hit me up on Twitter at BAMCTF. I'll listen to any suggestions you have and see what I can come up with. And yeah, all right, I'm ready for my weekend now. So next time, thanks for watching. If you want to like and subscribe, whatever, I don't care. It's your life. Do what you want. I'm not monetizing any of this, so I don't give a fuck. But yeah, next time you're doing a CTF, if you get stuck, don't forget, try harder, don't panic, and always RTFM. Cheers.
It's a madman.